So good afternoon, everyone, and welcome to this fourth statistics webinar on energy prices and energy efficiency indicators as part of the Sub-Saharan Africa Energy Data and Modeling Program. I'm very happy to be here today for this session on energy prices and energy efficiency indicators, after we have looked together at the fundamentals of statistics, at the statistics by commodities, and how to build energy balances and calculate CO2 emissions. So this session, it will be more about what data you need further to on energy to make better analysis and in order to guide your policies. So let's get started. So this is the agenda. So today, as I mentioned, we are closing the statistics modules, and as from tomorrow, my colleague Darlene will start the modeling sessions with the introduction to modeling, and you will have then 6 webinars on modeling, among which there will be 2 by our partners. And then we will look at the Sustainable Development Goal 7.1 and also solid biofuels, and we will then wrap up with the quiz and closing. So very quickly, before we start with the technical part, you are now familiar with this slide. So just some housekeeping rules to make our session the most effective. If you have any questions, please use the raise your hand button. And also you can send us all your questions through the Q&A box. Don't hesitate. Don't hesitate to send us any questions you might have. And also, if you have any other additional questions, you can write to me, to Darlene, or to the Africa program. So this is the agenda for today's webinars. We will start with energy prices. We will see why energy prices are important to collect, and we will look at some key statistical concepts on the methodologies for energy and use prices, and also for comparability. Then we'll do a small exercise together. Then we will look at energy efficiency indicators. We will see why is it important to develop these indicators, and what information is already available from the energy balances, and what further data are needed in order to track energy efficiency. We will also see how can we collect those data, and we will do a small exercise as well. So before we look at the presentation, let's quickly do some interactive questions using Menti on prices. So please start connecting to www.menti.com, and I will also do the same. Okay. So please connect to www.menti.com and use the code that appears on the screen here. In the chat box, I'll also put the link. And the code is 57, 71, 85, and 13. So please connect to www.menti.com using your phone or your computer, and put the code 57, 71, 18, 51, and 3, or you can use the link that I also put in the chat box to answer this first question. So let me. So the first question is, what are the different components in the end user price paid by the consumer for energy commodities such as electricity and natural gas? So think about your electricity bill, and in the electricity tariffs, what are the different components that make up for the price of the electricity that you are paying? Same for natural gas. If you're using natural gas, for example, for heating your house, the price that you're paying, what does it include? So I'll give you some time to answer. This is an open-ended question, so you can write down whatever you think makes up the price for electricity and natural gas. So for those people who just joined, please connect to www.menti.com and use the code that appears up on the screen, 57, 71, 85, and 13. So what are the different components in the end user price paid by the consumer for energy commodities such as electricity and natural gas? So there are some taxes, some transmission cost, infrastructure cost. Very good. Think about it. Operation and maintenance, generation, taxes, maintenance. Excellent. Yes. So as you will see, I mean, in the presentation, we'll look at all this in more details. There's the capital expenditure, reasonable return, depreciation, generation, exactly. So there's the ex-tax price that includes the cost of producing the electricity or the natural gas. So there's it contains the profit and all the different costs. But then there's also different taxes. So for taxes, maybe if you can detail what are the different taxes that that is included in the price, in the end user price that you're paying. Usually there are many, exactly, there's VAT, there's the value added taxes, there's also some excise duties, for example, for industries. There's some environmental taxes that are often applied. Exactly, very good. Let's look at the second question now. Are you aware of price tracking in your country? So yes or no, do you know if in Rwanda there's some agencies or is the ministry tracking those prices? Are these information available? So at the IEA, we have a team that works on energy prices and in statistics. So we collect end user prices we try to collect for as many countries in the world as possible. And for Rwanda, we are starting to collect as well. So we will organize a bilateral meeting with the team soon after the training to see together what data you are collecting, maybe how the IEA can support you here, and we can share information and best practices. And so for those people who are aware of the price data tracking, I would be interested to get in touch with you later to see what information can be shared with us and see what can be done together so that we can also publish those information if possible. Excellent. So next question, do prices data feed the policy work in your country? So for those who replied yes, the country was tracking prices. Do you know if those prices feed the policy work in your country? So there's 2 participants already who replied yes. Very good. It's very prices information. It's very important, especially when you are looking at affordability, when you're making analysis on poverty, and for many other reasons. So excellent. So all of you, for those who are replying, are saying yes, that those prices data feed the policy work in the country. Excellent. Let's look at the next question. Who is responsible for the price data collection in your country? So are you aware of some entities, ministries, or any other government entities that collect that data? So please tell us who. So RURA, yes, excellent. 2% said RURA. Is it the only government RURA? Very good. NISR. Excellent. So very good. So it's mainly RURA and 1% said NISR. Let's look at the next question. What are the challenges for prices data collection in the country? So are you aware of some challenges for collecting prices information? This is an open-ended question, so you can write down your answer. Why is it complicated to collect prices information? For some fuels, it's easier to collect. For others, it's more complicated. For example, for electricity, in many cases, it's a bit easier to collect it because usually there are tariffs. But for example, there are other fuels where it's more complicated, where there are different prices applied. For example, in the case of transport fuels, so you have different pump stations applying different prices in different regions. So then you have to make weighted averages, for example. Inconsistency of data, privacy policy. Yeah, there's also these confidentiality issues in some cases for some prices. So this is a big challenge. Yeah, staff. I agree that sometimes you need the people. You need people to run those surveys, to collect all this information. It's time consuming. It costs quite a lot to collect these prices data. It's a lot of work to process all this information, even though like for example, like gasoline and diesel, the prices is available, but if you have to collect it at every pump stations to get it for every region, then to make your national average, it takes time, and the prices also vary every day. So it depends whether you're going to report the price at a weekly level, monthly, quarterly, annual. At the IEA, we publish for non-OECD countries annual data, but we are also looking at publishing more disaggregated data at quarterly, monthly, weekly level, one day maybe daily also. So this is a lot of work to collect this information. Information asymmetry. Yes. So in the presentation, we will look at all these challenges, and so that We are all aware of them. So next one. Okay, so we'll keep the efficiency, the energy efficiency questions for when we do the second part. And now we will move to the presentation itself. So I will share again my screen on prices.
Why are energy prices important? Energy prices are important because they affect our lives as consumers and the competitiveness of a private enterprise, and therefore the economy of our country. End users' energy prices are influenced by price movements in the raw commodity markets. For instance, crude oil spot price market. The international spot price market is in turn affected to major events such as economic developments or even natural disasters. In the graph, we can see the step price decreases caused by global financial crisis in 2008-2009 and the oversupply in the market in year 2014. More recently, we can see the effect of the COVID pandemic on the market, with the reduction of the price linked to the reduction of the consumption. But the cost of the raw material and the international markets doesn't capture the full story. In fact, the end-use price paid by consumers is subject to taxation that might represent the major share of the final prices. Why do governments tax energy commodities? The taxation of energy products may pursue different objectives. The first objective could be public revenue generation. In the short, medium term, energy demand is relatively inelastic, making energy products good targets for revenue generation. Another objective could be internalizing the environmental and health costs associated to emissions or other types of pollution. The third objective of taxation is to drive the change. High taxation on the most polluting fossil fuels can help shift consumption towards a less polluting and therefore less taxed energy commodities. Tracking energy prices is important also because they represent a significant share of our daily lives expenditures. For households, for example, the direct expenditure on energy might represent up to 17% of the household spending. The same can be applied to industry. Industry competitiveness is greatly affected by energy costs. This is true especially for energy-intensive processes, such as aluminum production, for which energy costs can represent around 40% of the production costs. For all those reasons, it is very important to track energy prices in our country and to have an international methodology that allows us to compare prices across the world. Here at the IEA, we track energy prices across the world in the Energy Prices database. The map on this slide shows gasoline prices across the world drawn from this database. An accurate database is the basis for conducting accurate and robust analysis on the energy scenario and for assessing the competitiveness of a country. Such data also allows for evidence-based policymaking and energy transition planning. Robust data allow to draw comparison to regional differences. For example, thanks to this dataset, we can say that consumers in Africa pays on average the gasoline 30% less than the average of the world and 50% less than European consumers. This dataset enables also further analysis such as the one showed with this graph. This graph illustrates gasoline price levels across countries, based on GDP per capita, and it is taken from the IEA commentary on gasoline prices across the world. In this graph, we see that price levels are, in most countries, linked to the economic conjuncture of the country itself. Based on GDP per capita, we can identify 4 clusters of countries. Many developing countries fall in the cluster at the bottom left of the graph, since their governments often keep prices low to increase energy access. Please feel free to refer to the IEA commentary for further information and analysis on this topic. As mentioned before, it is important to have a common methodology for tracking energy price. This allows to have a solid international benchmark and comparable data. So let's now turn to the IEA methodology, which provides for such a common methodology and which has been adopted and used by other international organizations. End-use energy price is the sum of 2 subcomponents: ex-tax price and taxation, which is the sum of value-added tax and excise taxation. Having information on these components allows us to have a more solid understanding of the situation in the country and to draw policy implication and guide policy making. The ex-tax price includes all the costs incurred for producing the final product throughout the supply chain, except taxes. This includes the cost of raw materials, manufacturing costs, distribution costs, and profit. The excise taxation, instead, is generally levied on a volume basis and excludes the VAT component. This taxation might have different policy objectives and includes CO2 taxes, other environmental taxes, motor fuel taxes, emergency stock fees, and any other taxation applied to the commodity. And the last component is the VAT taxation. VAT taxation is a consumption tax on value added, and it is generally applied to the sum of the ex-tax price and excise taxation. As of 2020, over 170 countries had VAT or an equivalent taxes in place. To better understand each of those price components and how these can affect the end user price, let's have a look at a simple example of 2 hypothetical countries, A and B. Country A and country B have 2 different ex-tax prices for gasoline. This may depend on the different relative scarcity of the oil resources in the 2 countries or on different refinery and distribution costs. The government in country A decided to implement a lower excise taxation compared to country B, maybe to compensate the high ex-tax price. Country A has also a lower VAT rate compared to country B. So overall, the total taxation on gasoline in country A is lower than in country B. If we apply the VAT rate to the sum of the ex-tax and excise taxation, we obtain the VAT amount, which is summed to the excise tax, gives us the total taxation for fuel. As mentioned, the total taxation in country A is lower than the one in country B, and this makes the end user price lower despite the higher costs along the supply chain. Now let's delve into the methodology to calculate representative end user prices. What is the representative price for a country? Energy prices may vary across regions and provinces of the same country. For example, this map shows more expensive gasoline prices in the western parts of the United States compared to the prices in the southeastern states. Again, Using an example may help better understand. Let's consider a country, which we will call Statisland, with two provinces, Eastern Statisland and Western Statisland. In Eastern Statisland, the price of diesel is $0.5 per liter, while in Western Statisland, gasoline is more expensive, at $1 per liter. Diesel consumption is 500 kiloliters in the Eastern Statisland and just 100 kiloliters in the Western Statisland. If we calculated the simple arithmetical average of the two prices, we would have a $0.75 per liter. Is this a representative price? The answer is no, because as we can see from the input data, consumption is 5 times higher in the region with the lower price. Therefore, if we were to compute the simple average, we would not take into account this difference in consumption. In order to calculate a representative price, we need to weigh prices by consumption. If we take consumption into account, we obtain $0.558 per liter, which is the representative price for the country. When calculating a representative price, another important concept is the difference between prices and tariffs. In the data collection undertaken for our data tracking, we are interested in the prices, namely the average rate per unit actually paid by the consumers, no matter what is the price structure for the commodity in the country. Again, let's take a look at an example, this time on electricity prices. We all know that in general, the electricity bill has two components, fixed charges and the variable charges. The fixed charges pay for the connection to the grid, and it is not linked to the energy consumption. The variable component, on the contrary, is based on the quantity of energy consumed each month. In this case, to calculate the representative end user price for a user, we need to calculate the total electricity bill and divide it by the energy consumed. The total bill is the sum of fixed charges, 10 euros in this case, and the variable charges, which are 0.1 euros per kilowatt hour times 150 kilowatt hours. The total paid is 25 euros. The total now should be divided by the energy consumed, which is again 150 kilowatt hour. This gives the representative price for this consumer, which is 0.17 euros per kilowatt hour. To conclude, energy is an important component of our lives and for the economic development of our countries. And energy is a significant expenditure for our budgets. A solid energy price tracking system, one that allows having comprehensive and comparable data, is a key requirement for evidence-based policy making and policy choices to increase the energy affordability and foster a green and just transition. IEA stands ready to advise and support countries along this path. Please contact us to receive more information on how IEA can support your country develop more solid energy price tracking systems that will support sound and effective policy choices. Thanks.
So I hope that this presentation on energy prices was useful to you. If you have any question regarding the presentation, please let us know. I've been joined also by my colleague Alexandre Wiesel, who works on in the energy prices team. Hi, Alex.
Hi, Zakia. Hi, everyone. I hope this presentation was useful to everyone. And if you have any question, clarification, please feel free.
If you have any question, please write it down in the Q&A box. Yeah, and if you have questions even after, you can write to prices@iea.org. Alexandre has put it in the chat box. And he also shared with you the IEA website link on energy prices. So on the website, we have a dedicated page where we put all our resources. No question. Let me see if there are some raised hands. I've not checked yet. No. Are there people in the participants who work on prices data collection directly? Are there people here? No. Then maybe Alex, you can present maybe the IEA prices database.
Yeah, so yeah, maybe the presentation was a bit compact, so let you digest a bit the presentation, but I can show you, yeah, what do we have overall, what's available online, just to get a sense how those data can be used and why to connect.
Yeah.
And yeah, Rwanda prices are recorded by Hura, yeah, which is also the source that we use for prices for Rwanda. I believe we do publish some transport fuels prices for Rwanda, as well as some electricity prices, if I'm not mistaken. So which screen can you see now? Can you see the web page?
Yeah, I can see the prices overview. Yeah.
Right. So yeah, this data product is not for free to all users. This is not yet a free database. However, we put some analyses and insights in the landing page that I put in the chat here. So especially in the overview. So here in global trend, for instance, we update this once a year. The database is updated twice a year, actually. This is a global map for the gasoline prices here, where we can see, yeah, should have Rwanda here at nominal rates, and we also do collect the data in terms of the regulation for gasoline. So is the price fixed, liberalized? So this goes beyond the price, but it's more on the part of taxation regulation, but that's also very useful information for analysis. Those are more difficult, data information to get sometimes to understand the structure of the price build among the countries. So that's where it's very important for us to have to be in touch with some experts with the countries, with the experts from the ministries or the regulatory authorities. So that's enabled to compare the prices along with the level of regulation for the countries. We also collect some taxation data for some countries, and we try to break down even further with the share of environmental taxes for gasoline, for instance. And that's where we can compute as well some world average, consumption average figures that enable to compare the countries among others. Here we have a selection of weekly prices, for instance, for a selection of few countries. But the database includes over 100, we have 135 countries covered here. Mostly for oil product transport fuels, but also for electricity and other fuels. Expanded until regional prices as well for a few countries. So building from this, we made a commentary which is basically an analysis based from the database. So I will just put here the link in the chat, which is, I think, a good example of what can be drawn from this database and why we should collect some prices and taxes data. So in this commentary, we are basically showing the average prices for those categories of countries, those that are the price fixed, intermediate, or liberalized in those very, very simple categories. And that's where we can get some useful insight in terms of we can identify from this, for instance, where are the oil producer countries, for instance, here with high GDP or low gasoline price, and that enables to draw some analysis from the database. And I very much encourage you to have a read through it if you are interested, and it can give good insight in how this can be used. So the full database is not for free here, but if you have an interest, if you are interested in this for your work, please get in touch with prices@iea.org. This is what we think one of the database with the best coverage in terms of countries and products.
Yes, as Alexandre said, even though this full database, it's not for free, but we do share it with our countries, so with ministries, with the governments, as required. So if you need any of our data for Rwanda, then please get in touch with us. And we are also planning to have a bilateral meeting to see also how we can improve our database, maybe collect more information that is available on your side that maybe we don't know, or if you need any advice from the prices team on how to better report on some methodologies, don't hesitate also to get in touch. So I don't see any questions, so then I think we can move on with the exercise. So thanks a lot, Alex, for joining and for showing a bit the website to the participants, because it's true that the IEA website has plenty of information, but many people are not aware of all the resources that are available. So that was nice of you. So now let's move to the exercise on prices. So I don't know if any of you, any participants got the time to look at this prices exercise. So we provided you with some countries with country A data from household surveys, and And so you got data from households, average spending for heating and cooking, average consumption of natural gas for the residential sector for 2019. You got some taxes information, so some VAT and excise tax. And there was also some information provided from gas provider for industrial consumers, so gas data. So you got revenues information and the amount of natural gas sold to industrial consumers. There was also some information provided from power plants annual surveys. So you got the information of average purchase price of natural gas in 2015, excluding excise tax. So the first question was, after discussing with the gas suppliers and the National Statistics Office, you obtained data from the household survey, tax information and revenue. So the first question was, calculate the average natural gas price for households, industry and electric utilities. So we provided you with some hints. So first, to calculate the average total price for household as value divided by quantity, calculate the rest of the data, remembering that households do not pay excise taxes in this case, and also to calculate 2019 for industry and electricity generation. So here we have to fill out those tables. So the first thing that we can fill out easily is the VAT percentage. So we know that consumers, so household, residential, pay 20% tax, VAT tax. So you know already this amount, and you know that industries do not pay VAT, electricity plants do not pay VAT. So you already fill out these three cells. Then you know that excise tax, residential don't pay excise tax, so you put a 0 here. You know that industries do pay excise tax, so it's 32 euros, so 31.9 euro per megawatt hour. And you also know that for electricity plants, it's 32 as well. So that was, so you know the VAT amount and the excise tax. So let's look for household one by one. So then what do we know more? We know that we know the total price because we can calculate it as the average spending for heating and cooking, and you divide it by the quantity. So then you get the total price paid by the residential for natural gas in euro per megawatt hour. So you know this amount. You know the total price, you know the VAT amount. So we need to back calculate the ex-tax price. So the ex-tax price, you back calculate it. So you take your total price and you divide it by 1 plus 20%, and you get your ex-tax price. Now you can calculate your VAT amount, which is 20% of your ex-tax price, which gives you 227. So your total tax is just the VAT amount, which is 227. So that was for households. For industries, you know the excise tax, you know that there's no VAT, so your total tax is just equal to your excise tax. And what else do we know? We know that the ex-tax price, we can calculate that because we know the revenues and we know how much natural gas was sold to industries. So you take your revenue, you divide it by your natural gas sold. But here, the amount of natural gas, it's in gigawatt hour GCV, and here we are reporting in megawatt hour. So you need to convert as well from giga to mega. So when you're dividing, so you do total revenue divided by your natural gas sold, the quantity times 1 million. So you get 902. So you know your ex-tax price, you know your total tax. So the total price is the sum of the two. So 902 plus 32. So that was for industry. Let's do for electricity power plants now. So here we know the excise tax, we know the VAT is 0, so your total tax is 32. What do we know more? We know the average purchase price of natural gas. It was 735 euro per megawatt hour, but this was in NCV. It was in net calorific value. And here we are looking to report in gross calorific value. So here when you're taking your amount of average purchase price, you have to multiply by 0.9 to get your electricity in gross calorific value. And so for total price, you just sum the ex-tax price plus the total tax. So that was the first question. The second one is calculate the growth of natural gas prices between 2010 and 2019. So can you say that prices increased since 2010? If not, how could you modify the prices to have a better comparison in time? So here, if we calculate in red here, we can calculate a simple average growth rate. So here you take your amount in 2019, you divide it by your amount in 2010, and you do -1 to get the growth rate. So here you get an increase of 18%. So here for household, just by doing a simple growth rate, 2019 value divided by 2010 -1, you get 18%. So here, this comparison, it does not take into account inflation. So here, can we say that prices increase? Not really. If not, how could you modify the prices to have a better comparison in time? So here we need a deflator to better make this comparison. And in this case, for residential, we need a consumer price index, since these are household prices, and we need this CPI to be applied. So using the average available consumer price index, recalculate total prices for 2010 and 2019 and the new growth rate. So here we are provided with the consumer price index for 2010 and 2019, where 2015 is equal to 1 for the index. So if we recalculate now, so for 2010, the adjusted price would be, you take your total price times your CPI, you divide it by your CPI, and the adjusted price is 1,271. Same for 2019, you take your 2019 total price, you divide by your CPI, and you get this. And now if you recalculate the growth rate, you will see that there's a decline in real terms. So you get -5%. So we see that when we have corrected the prices for inflation, then natural gas prices is actually declining instead of increasing by 18%. So it's very important when you're comparing different years to make these adjustments and to deflate properly for inflation. In order to get a real sense of the trend. So that was the exercise on prices, and now we can move on again to the second part of the session on energy efficiency indicators, and we'll do some Menti. So can you please again connect to www.menti.com and use the code that appears up on the screen? So it's the same code as before, 57, 71, 85, and 13. So the question was, what do you think when we speak about energy efficiency? So some participants are saying it's efficient usage of energy, it's to save energy. Yes. Uninterrupted energy, use less energy to do more. Yes. So when energy efficiency at the IEA, we often say that energy efficiency is the first fuel. So we have many answers arriving. It's amount of energy to sustainability, produce the need. Yes. Ability to use the maximum. Yeah. So very good. So in the presentation, we will look at this in more details, but I think everyone got the idea of what is energy efficiency. The next question is, what is energy efficiency? So is it to consume less energy to provide the same service? Example, using LED bulbs instead of incandescents. Is it to consume same energy to provide more service? So for example, to increase production of steel. Is it to consume less energy because of a change in service? For example, if there's an economic restructuring from heavy industry to services, or is it to consume less energy and provide less service? For example, if you're biking instead of driving to work. So here you can put several answers. There are several good answers. So don't hesitate to choose more than one. So we have more participants saying it's to consume less energy to provide the same service. We also have 3 who say consume same energy to provide more service. 1 who said the third one and 1 who said the last one. So as I said, you can put multiple answers. There's not one single correct one. So let's look at the right answers. So the right answer, it's the first two. So energy efficiency, it's to consume less energy to provide the same service, but it's also to consume the same energy and to provide more service. So there's two ways. Next question. Is energy intensity of the economy, so total energy supply divided by GDP, a good indicator of energy efficiency? So very often we use energy intensity, which is calculated as total energy supply. So your total energy supply, you can find it in your energy balance. If you take this total energy supply, you divide by your GDP, Is it a good indicator of energy energy efficiency? I'm sorry. Energy intensity, it's widely used because it's an indicator that it's easy to get the information from the energy balance for the total energy supply, and GDP information also is readily available. But is that enough for you to say, is it, you know, if your energy intensity it's decreasing by calculating total energy supply by GDP over the year, from one year to another, does it mean that this is due to energy efficiency? So you have mixed feelings. We have two who says yes, another two participants who's saying no. In the exercise session, we have this question with some real numbers to think. So those who maybe look at the exercise knows the answer already. So let's look at the right answer, and the right answer, it's no, it's not enough. Even though widely used, to really look at energy efficiency, we need more disaggregated data at sectoral levels to really understand whether the effect of a decrease in consumption it's due to energy efficiency improvements or not. So just looking at energy intensity, it's not enough at all. So I think that was the last Menti. So now we'll move to the presentation.
So why energy efficiency is important, and why do we need energy efficiency indicators? Usually, when we think about energy efficiency and why it's necessary, we'll think about the reduction in energy consumption. However, there are many other benefits from energy efficiency. Here we can see what we call the energy efficiency flower, representing multiple benefits from energy efficiency improvement. Those benefits can be economic, social, environmental. For example, by increasing employment, increasing energy security, or by reducing harmful emissions. This is why many countries have set energy efficiency targets, and this is why it's important to have end-use data to track the progress of energy efficiency policies and to be able to set the correct target for those policies. Here we can see policy design examples, but also benchmarking exercises, which are an important application of this kind of data. However, there is still a very high portion of energy consumption that is not covered by energy efficiency policies, and this represents a large potential for action. Only 35% of the global energy consumption is subject to mandatory efficiency standards. And it's estimated that in Africa, only 2% of energy demand is covered by energy efficiency policies. This is why it's very important to have detailed data in order to be able to study energy efficiency trends in depth, to know the priority areas and where we stand, to set the targets, and to track and monitor the actions. But now, let's see what kind of data are already available from the energy balances. Energy balances give a very useful piece of information, and combined with some macroeconomic data, allows to calculate aggregated indicators, like for example, the energy intensity. However, there are limitations in terms of the disaggregation of the data. For example, in an energy balance, the residential and the services sector are represented as total, while in order to study energy efficiency, we would need a further disaggregation by end use. For example, space cooling and space heating. One of the possible starting points to identify priorities in the breakdown of final energy consumption by sector. Usually this information can be easily extracted from the energy balance of a country. So, for example, in this case, we can identify that the residential sector is the most consuming, so it's likely to be considered a priority sector for energy savings. However, we need more detailed data to better assess this, like for example, the consumption by end use, such as cooking, water heating, or space cooling, and the related activity data, like number of occupied dwellings or surface. Not having proper data could lead to wrong policy decisions and actions. Let's see now an example of widely used, the energy intensity. We can see a figure illustrating the energy intensity trends for different regions since 2000 to 2018. Energy intensity is commonly used as a proxy for energy efficiency. However, the indicator is too high level and includes different factors, such as the structure of an economy or the activity, besides real efficiency. So in order to study efficiency, we need more detailed data. Let's see another example where we study the residential sector trends, starting by using the most aggregated data to using the most detailed one. If we analyze the residential consumption over 20 years, shown in the graph in the blue line, we see that there has been an increase as a whole, plus 15%. However, we can see that the consumption per capita, the red line, is at the same levels at the end of the period, more or less. If we go to the more detailed data indicators, for example, the consumption of energy for space heating divided by occupied dwellings or by floor area, we can see a dramatic reduction over the analyzed period. So this means that even if residential energy consumption increased and residential consumption per capita did more or less remain stable, important efficiency improvements are witnessed in space heating. The residential per capita indicator did not show any change even with the big efficiency improvements in some end uses, probably because of the increased use of new appliances, such as smartphones, computers, tablets. So all in all, it is essential to choose the most appropriate indicator depending on what do we want to observe. If we just look at the total residential energy consumption, we would observe that the total final energy consumption has increased by 15%. However, this does not mean that we are less efficient now. For instance, the residential space heating energy consumption per floor area has decreased 35%. So it's really important to choose the proper indicator depending on the message we want to give and what we want to observe. So what drives energy intensity then? The efficiency progress is one of the drivers. For example, more efficient industrial processes will contribute to a lower overall intensity. But there are also other factors like the increase of the activity, for example, the increase of population, more houses, more cars, or the structural change of an economy. For example, a country switching from the industry to the service sector, which is less energy intensive, that all also affect the energy intensity. So it's really important to differentiate which improvements come from improvement in energy efficiency to track the impact of energy efficiency policies. Here, for example, we can see how energy efficiency helps to decrease the overall energy consumption, while the increase in the activity contributes to the opposite. So, what additional data are needed in order to study energy efficiency? As we have seen from the energy balances information, we can create some energy indicators such as the total final consumption per population. However, those indicators are not specific enough to monitor energy efficiency. In order to study energy efficiency and obtain energy efficiency indicators, we need end-use data or even more disaggregated data. However, the greater the disaggregation, the more data are needed, and usually this also comes with higher cost. Collecting data is costly, but enables a better design, monitoring, and evaluation of policy. Not having proper data could lead, as we said before, to incorrect decisions and actions, and as a consequence, to even higher costs. Also, in order to develop indicators, apart from energy consumption data, it is essential to also collect activity data. The activity data are sector specific. It could be a physical production of a certain commodity like cement or steel, floor area, or the distance driven by a vehicle. Combining energy consumption and activity data, we can obtain efficiency indicators that explain how much energy is needed to provide a certain service. For instance, how much energy is needed to produce a ton of steel. Let's now see which data we can collect for every sector. And let's start with the residential sector. In order to calculate energy efficiency indicators for the residential sector, the IEA recommends collecting energy consumption data by end use. So, for example, space heating and cooling, water heating, cooking, lighting, as well as energy consumption of different appliances, such as dishwashers or televisions. It's also important to collect data on heating degree days and cooling degree days in order to be able to correct space heating and space cooling energy consumption for the year-to-year variation of the temperature. In other words, when we analyze energy efficiency indicators for space heating and space cooling, we want to observe change in the energy consumption resulting from the energy efficiency improvements and not from the climate effect over this consumption. If the winter is harder, then it's very likely that people are going to consume more energy for space heating, for example. And we want to avoid this effect. Regarding the activity data for the residential sector, we could collect information on the number of dwellings, particularly occupied dwellings, residential floor area, as well as stocks of different types of appliances. We should also pay attention to the activity data we use for our indicators. For example, if we use total dwellings, we will also account for abandoned dwellings and secondary residences. Therefore, in order to avoid counting in efficiency empty buildings which does not consume, we should exclude vacation homes and unoccupied dwellings. And so this way we keep the same boundaries between the energy consumption and the activity related to this energy consumption. Let's now have a look at what we can do in terms of data collection for the service sector. For energy, we can also collect data by end use. So for example, space heating and cooling, lighting, other energy uses in service buildings, and also non-building energy use, for example, street lighting. We can also collect electricity and other fuel consumption data and floor area by IC categories instead of by end use. But it's also good to do for both end use and IC categories. And the most relevant activity data would be the value added, the floor area, or the number of employees, for example. The next sector is industry, and for energy, in the IEA, we collect data for 19 major ISIC subsectors. And when it's possible, we encourage more detailed data collections. For example, energy consumed to produce aluminium or cement, since this data collection allows for physical indicators that are more detailed than the major ISIC categories. And when it comes to activity data, we focus on the value added created by a given subsector. But for certain energy intensive and homogeneous industries like paper and iron and steel, we can collect also the data on the physical production, such as the tons of steel produced. And finally, the transport sector. It might seem a little bit more complicated than the other sectors because here we differentiate between transport segments and modes. So segments include passenger and freight transport, while modes refer to road, rail, air, and water. Regarding the activity for the transport sector, we want to observe how much and how far we can move. So for instance, how many passenger or tons of goods we can move and how far. To measure this, we use vehicle stocks, vehicle kilometers, passenger kilometers, ton kilometers, and we calculate passenger kilometers and ton kilometers as the total distance traveled by all the vehicle stocks that we are analyzing, multiplied by the occupancy for passenger transport or by the load factor in case of the freight transport. But how can we collect all this data we are mentioning? So in 2009, the IEA members countries agreed on the new energy efficiency indicators data collection. Thanks to the cooperation with international experts, an Excel template was developed, and you can find this template already in the IEA website. And with this template, the IEA collects both energy and activity data for all the four sectors presented: residential, services, industry, and transport. In December, we published the energy efficiency indicators database and a report called Energy Efficiency Indicators Highlight, where we include all the countries that collaborate with us, not only members. We are open to collaborate with any country that would like to do so. And this report, of course, is also available online free of charge. And on top of that, the IEA has also cooperated with AFREC to develop a questionnaire for energy efficiency, particularly for the residential sector. So on the country level, the IEA differentiates four main data collection methods. And firstly, before starting any new data collection, it's good to make sure that this data is not already collected. So for instance, if you need some activity data for transport sector, it is possible that the Ministry of Transport is already has this data. So it's very important to map where all the data that I need might be located. If you're sure that these data are not available, you can start your own data collection by launching, for example, a new survey, or you can even decide for a less expensive options, which could be expanding an already existing survey. For example, adding some transport questions on a household surveys. Another method is metering and measuring that is relatively costly, but really effective if you want to measure efficiency of some specific equipment. And here we can also find, for example, smart meters, which are more and more used nowadays. And we also have modeling, which is the last of the four methods, and it can be complementary to surveys and metering or used standalone. For instance, by using activity data and total energy consumption data from the energy balances as input to estimate energy consumption by end use, for example. The IEA has developed two manuals. The first one is the Fundamentals on Statistics and provides guidance on how to collect data and how to develop those efficiency indicators. And it includes also a compilation of existing practices of data collection from across the world. And the second one is the Essentials for Policymakers, which advise on how to develop those indicators as well, and particularly how to interpret the energy efficiency indicators. Both manuals are available on the IEA website in English, Spanish, Russian, Chinese, and also French. Before starting any data collection, it's always useful to have a look at what other countries have done. For this purpose, the IEA developed the country practice database, which is a very useful resource to learn from each other. It's a very powerful tool worth consulting before undertaking any new data collection, because it allows seeing what other countries did and to take an advantage of their experience. For example, if you are planning to develop a new data collection, such as a new household survey, for example, you can check what other countries have done and even the details of that survey, the results, and even the questionnaire of that survey. And also, if you have a country practice that you wish to share, please contact us so we can make it available for others and others can benefit from your expertise. I would like to conclude with some key messages. First of all, detailed energy and activity end-use data are crucial for well-informed and effective policies. These data are essential for identifying priority sectors and understanding energy efficiency trends and monitoring policy effectiveness. Therefore, it's extremely important to raise people's awareness of the detailed data needs and underline benefits of country-specific data collection and analysis. It's also important to benefit from the experience of other countries and organizations, as well as contributing to this. So we invite all countries that want to start collaborating with us on end-use data and efficiency indicators to reach out, and we can discuss in more detail the potential collaborations we could develop with you.
So I hope that this presentation on energy efficiency indicators was useful to you. I've been joined by my colleague Domenico Latanzio, who's statistics manager for energy efficiency. So if you have any questions, please don't hesitate to send it to us in the Q&A box or to raise your hand and I will allow you. I give the floor to you to speak.
Hi, good afternoon, everybody.
Hi, Domenico. I don't know if in the participants there are some people who work on the topic, who are calculating some energy efficiency indicators, or developing some such indicators.
I have shared the link also of the main page of the highlights of the publication that we publish. We publish twice per year, and here you can find useful and interesting metrics that can be used a bit to understand what is the what is the data that we are collecting and that we publish. I don't know, maybe I can quickly share.
Yeah.
Okay, you see the web page, right? Okay.
Yeah, we can see. Yeah.
Okay, so here there is an interactive tool that you can use, as you can just navigate a bit the data. We think it is important. I mean, it's clear that this a further effort compared to the energy balance. So if you see here in the Sankey diagram, the energy balance usually stops here at this level. So transport, manufacturing, residential, services, and other sectors. But it's important really to inform policy to have also the detailed breakdown. Because if we are thinking about residential, for instance, and we want to tackle the space heating, we need to know how much space heating represents in the consumption. So we really favor this work, and then we would suggest to look into this, and especially to maybe not all the sectors if the resources are not there, but targeting the sectors that you think are more relevant for your specific country. So for instance, there are countries where paper is really relevant, so they are doing some detailed work on this area. We have been talking with some of those countries. So it's literally we need to identify first the sector for which we need some better metrics, and then go farther down into the breakdown. And we are happy to hear from you if you do anything similar, if you have thought about anything similar. For instance, also transport is a sector that usually draws a lot of attention, because transport represents a big it's a big share of the emission and the energy used in the country in general. So in general, this is also really looked at.
Yeah, it would be interesting to know if in Rwanda you have started some projects to further improve your surveys, to collect these detailed information. It would be good to know if you have started thinking about this, or you have already maybe done it and we are not aware. So if you have done such work, don't hesitate to share with us. We are very interested in knowing what countries are doing in that sphere. There's a question in the Q&A box, Domenico from Silas. What is the indicator of energy governed by policy? I'm not sure I get it. I understand well what Silas meant. Maybe Silas, if you want to take the floor and explain to us your question.
Hello?
Hello.
Hello.
Yes, my question is, in this presentation, there is somewhere I have seen there is 2% of Africa energy is governed by policy. So I need know
the connection is not good.
2% of energy governed by policy. Is it from?
Yes.
This presentation, there is somewhere you have seen 2% of Africa energy is governed by policy. Yeah,
okay.
If you have 2% governed by policy.
Oh, I see what you mean. Okay.
Percent aware.
Okay, I share that slide. I see what you mean.
Yeah, I think that was a collection of the colleagues of the energy efficiency division. I think you're referring to this slide where they just calculated how much energy efficiency policy are covering over the total.
Yeah, it's this slide.
Yeah. So this means that if you have, for instance, the labeling system in place for refrigerators, this is under energy efficiency policy development. If you have, I don't know, policy for residential that just put some boundaries on the efficiency of the new buildings, for instance, or if you have the fuel economy standards for the new cars in the market, this is the kind of policies that are meant to cover the final consumption. So this slide was referring to this exactly. Things might have slightly changed because this is a publication from 2020, and maybe there are more policies covering more sectors, but just to give a broad idea on the coverage and the potential that energy efficiency has into the energy world, we estimate that the 40% of the emissions savings will to 2050 will come from energy efficiency measures. And in general, is a win-win situation, because whenever you reduce the use of energy, you're less dependent, it's more economic. Also the use of the transport or the residential, and in general also fosters employment, because in general energy efficiency measures, if I'm thinking to residential, it's evident they need a lot of workers that for renovating the building stock, and so it's really a win-win situation for the economy and for the energy world. And also putting some labeling system in place, for instance, as the one that in countries is always present, like exists, like in Europe, there is the labeling system for all the appliances, or in general across the different regions, there is always a policy for appliances, and this also changes the use of energy into the residential, for instance. We see this with the transport and other the main on every key sector, also in industry, where you can have more targeted metrics to assess the situation and then to set targets for the future.
Yeah. I think this information, Domenico, we have it just by region, right? We don't have it by country or by sub-regions.
You mean the one that you're showing?
Yeah.
Yeah.
The percentage that is covered and not covered. Yeah.
Yes, it's taken, and it's a research that is done by the colleagues publishing the energy efficiency review.
Yeah. Okay. Any other question?
I can also mention that we are currently working on a roadmap that will allow countries to set in place a process for calculating energy efficiency indicators. So we know that is a huge effort. So we are trying to put together the ideal path that the country that doesn't have in place any data collection on this space can follow. So basically, it's step by step. It's how to implement this data collection, and we are also integrating this with specific experiences in specific countries. So where we are also drafting the part where we present the experience done in this specific country, how this became important in that country, and how the system is working. This is a bit to inspire also the others to either to take something that is really working well in other countries and implementing it at national level, or can be used also as a leverage to set up a process for data collection and energy efficiency indicators.
Yeah. And you're doing some case studies with countries as well, right?
Yes, we are interviewing countries that have this experience, and they tell us how they implemented the data collection in their country. And so we will include those experiences as best practices in this roadmap. So feel free to reach out to me if you think this is relevant for you, and if you think it's useful. We are still drafting the document, but it will be published soon, later in the year, I imagine.
Yeah, I'll make sure to share it with our countries that we are working in Africa. I see two more questions. We need more explanation on the key message to retain. Thanks.
So I think the key message here is that energy balance,
yeah,
is key and is important, but it's the first step in the understanding of what's going on in the country. So it gives the idea of what sectors are important and where the country is using energy and where is also emitting emissions. And this is key and crucial, and it's welcome when you work on that. But it's key to develop further indicators, a further breakdown of the use of the energy, to be able to understand and set up targeted policies. Let's say, I know that, for instance, this image is very telling. Okay, we're saying that 70% of the energy is used in residential, but then I'm wondering, okay, I want to reduce this consumption of energy, or I want to handle this use, but I don't know where the energy is going in residential. Is this used for cooling? Is this used for heating? Is this used for cooking? Is this used for refrigerators, for appliances? I don't know. I don't have the understanding of where this energy is used. So I need to have the further breakdown of the energy. I would like to see in residential, what's the share for cooking, what's the share for heating, what's the share for appliances. Once I know that, I want to know what's the activity data behind this. Let's say in 5 years, the consumption of energy for heating is increasing, but this is increasing. What's the driver of this increase? And there it comes, okay, the surface, the population. I need to understand what's driving this consumption. So for this, I need to create an indicator, a specific indicator on the specific use that I'm looking at. And therefore, the key message is always create the right indicator. Try to think about the indicator that you would like to have to describe your country, and the indicator that is needed for the policy to be implemented. And this is like a great example what Zaki is showing. Total residential. This is in a country. Total residential increased in this slide, but what was the driver there? So if I decouple the different drivers, I see that residential space per floor area, which is the orange line, was indeed decreasing. So it means that I'm more efficient in the use of energy. If I had only the first level of information, which is the total residential, and I saw plus 15%, I could have thought that was just increasing the energy use, and we were decreasing the efficiency in the country. But this is not the case. So to target the reduction that I want, I need to decouple all the effects, and then to be able then to play on the effect on the drivers.
Yeah. So indeed, it's very important to go beyond the energy balances and and understand the other factors. Yeah, I think there was this last slide, not this one. And also being aware of the different methods to collect data, because sometimes countries just focus on one or two, but there are other methods. So being aware of the different methods and trying to see what best fits your needs, and taking, I mean, being aware and making use of all the possible sources. It's important to.
I see another question is, hello, in a country with excess generation, do you consider energy efficiency measure to be implemented effectively, considering the demand which is not growing at a great pace? What would be your advice based on experience in rental and energy efficient measures in such scenario? So my understanding here is that you're saying that in your country you have more generation than uses, and which is something that can happen in a country, especially whenever. So first of all, this already can be seen as, okay, the question here is why there is more generation than use. So like the answers, I don't know the specific situation, but the answer could have been, okay, we were not able to foresee the energy consumption, the future of the energy consumption. And this is something that another country experienced at some point. Those indicators are always also useful, especially for the electricity market, to foresee the future consumption of the in the market. So we know that for the electricity market, transmissions are crucial, and also generation is crucial. And then to build new generation plants, you need a lot of time, and transmission lines are really costly and hard to build. And we had an example where there were some models that they were foreseeing a great increase of energy consumption in a specific country, and they started creating a lot of transmission lines, a lot of power plants, and then they realized that the increase of use of electricity was not what they foreseen. This is exactly why, this is another reason why you should have a good understanding of how energy is used, to be able to foresee what's the future use of the energy. So if you have an indicator and you say, okay, I have heat pumps coming into residential for heating, and then given this information, you're able also to foresee where you will go. So this is the first angle of my answer. The second point to my answer would be, yes, energy efficiency is always important, even if you have the generation that can supply like no matter what energy you need. Because of course, if you use more energy, you're also paying more, because like energy is a cost. You're also need to maybe import more energy, and maybe you're just avoiding, maybe you can export that energy to the neighbor country to sell it, for instance. So there are like, it's always a benefit to avoid the use of energy. So efficiency is always key, even if you feel that you have the resources and the generation capacity. And this applies to electricity, but also to any other fuel.
Yeah, trying to match your supply with your demand, it's important. So that's why it's very important to make for countries to forecast well future demands. But even if this happened, then adjusting then your supply to match your demand, I think that's where we need to make efforts. Yeah.
If you have more energy, for instance, like more generation capacity that is able to provide energy at low cost, if you reduce the use of energy, this also can boost a bit the industry, because the industry will have access to more power with less cost, and this is always a benefit for the country.
Yeah. In this case, also, I think what could be done is to see which power plants are less efficient. So maybe closing for maintenance, or even just closing old power plants that's consuming too much energy could be useful. I don't see any other questions, so then I think we can move on to the exercise session. Let me see if there are any raised hands before we move out. No. So thanks a lot, Domenico, for joining for this Q&A session. So now I'll just move to the exercise.
Thank you very much. Thank you very much, Zakia. Thank you all for the questions. And
yeah, if you have any other questions related to energy efficiency indicators, don't hesitate to write to me or to the energy indicators at IEA.org, and we will be very happy to get in touch and reply. We'll also try to organize bilateral meetings after on this topic with people who work on the topic. So if you know any people, even who are not in the meeting today, who work on the topic, with whom we can have a conversation to understand what are you working on in Rwanda, what kind of support the IEA can provide in terms of methodology, advice, please let us know, send to us the contacts of those people, and we will organize a meeting with them in the coming weeks to discuss bilaterally on this. So now this was the exercise that we sent to you on the topic. So you have a simplified energy balance for 2019 for country A, where you had the supply part, the transformation, and the total final consumption by sector. So you have all the information in terajoules and CV for the different products and the total. So the first question is calculate 2019 energy intensity for country A. So you are provided with the GDP for country A, and you're asked to calculate the energy intensity. So if you remember in the Menti question, to calculate energy intensity, you take your total energy supply and you divide it by your GDP. So here your energy intensity is 5.25 megajoule per 2015 PPP US dollars. And then you're provided with the energy intensity of 2010, which is 7.8. And the question two is, did the energy intensity decrease since 2010? If yes, can you say that this was due to the improvements in energy efficiency? So if we just look at it like that, we see that, yes, it decreased because it was 7.8, now it's 5.25. So we see that the intensity decreased. However, we cannot say for sure just by looking at the energy intensity aggregated indicator that this is due to the improvement in energy efficiency. So this decrease, it can be due to several reasons. It can be due to an economical shift towards higher share of less energy intensive industries and more towards services. So we need more disaggregated energy and activity data for all the sectors and subsectors in order to analyze energy efficiency. Then for question 3, we are provided with more information. So here you are given the activity data. So how much is the production of iron and steel in tons, cement production, then some value added for different sectors. So then you're asked, using those activity data, calculate the energy efficiency indicator for each of the 4 industry subsectors. So for iron and steel energy intensity, since we have the physical production of iron and steel, so the preferred efficiency indicator will be to use the physical production in tons. So how much energy is required, for example, to produce 1 ton of steel. So, and for the other sectors where we don't have the production values, so so for iron and steel and cement we have production, but for machinery, for example, we don't have, then for these we will use the value added indicator. So for iron and steel energy intensity, we will calculate it as the total energy consumed in iron and steel divided by the iron and steel production here. So the unit will be in gigajoule per ton. So you get 24. Same for cement consumption divided by cement production. But for machinery, we don't have the production values. So here we will use value added. And anyway, value added, as you can see, it's related to revenues, and in a certain sense, it's also linked to physical production. So here what we will do is we take the machinery consumption and we divide it by the machinery value added. Then the unit will be megajoule per 2015 US dollars ppb. Same for other manufacturing. We have the other manufacturing value added. So here you take your other manufacturing energy consumption divided by other manufacturing value added. So these are the best energy efficiency indicators with given information. So having said that, when you need to remember that when you use value added for efficiency indicators, it brings a certain noise because you could have different prices. Same like when we were looking at prices, it's important when you're comparing different years to take this into account. So here it's important to use constant prices, value added, in order to remove the inflation noise. So here for industry, here we provide you with the units already. So here we are looking at the value added. So for industry value, here you take your total industry divided by your industry value added. For iron and steel, it's the same. Iron and steel consumption divided by iron and steel value added, and same for cement. So the last question was, the table below shows energy efficiency indicators based on value added. So you're provided with this information for 2010 and 2019. So calculate the average annual growth rate or the total growth for each sector. What can you say about efficiency improvement in each of these sectors? So here we will calculate the compound average growth rate from 2010 to 2019. So the way to calculate it is to take your 2019 value for iron and steel, you divide it by your 2010 value, then you put it to the power of 1 minus 2019 minus 2010 over minus 1. So then you get the compound average growth rate for iron and steel energy intensity. You apply the same for cement and clinker, machinery and other manufacturing, same formula here. So you can see, what can we see here? It's that all the sectors decline. So iron and steel is declining, machinery is declining, other manufacturing, it's declining, except cement. That is increasing. And this decline, the decline for these indicators, except cement, might be due to efficiency improvement, for example, retrofitting of existing plants or the beginning of operation of new and more efficient plants. For cement sector, we see that there's an increase in the energy efficiency indicator of around 2%. And this can be due, for example, to aging plants, but also to other factors. For example, the country is importing more clinker which is the raw material to produce cement, and now is producing more cement inside the country, which increased the demand, energy demand for its production. For other manufacturing, given that we don't have more details on this sector, we don't know exactly. So this can be due to, for example, a big shift in the structure, but we don't know. So that was the exercise. I really recommend you to try to do it by yourself, both for the prices exercise and for this one. And let me know if you have any other question. Otherwise, that was it for me. I hope that as we close the statistics, the 4 statistics session today, that it was useful to you, and that you have learned many things, and that it will be useful to your work. Tomorrow you will start with the modeling, which is also very interesting and useful with Darlene, and I will not be joining those sessions. So if you have any question regarding the statistics webinars, please write down to me and I will be very happy to reply to you. Please let me know if you have any question before we close up today's session. No question? Then I wish you all a very nice afternoon, and see you. So I will join again for the SDG and solid biofuel session. So have a nice modeling session with Darlene until we meet next time. Bye everyone.